Hello class, this is a continuation on the revision of Year 11 transformations. In this video, we'll be looking at reflections. So to reflect on the y-axis, once again, it's actually a substitution of letting x become negative x. I want you to start thinking about this as, rather than a reflection on the x-axis, think of it as a horizontal reflection. That way it's more easy to remember that x is horizontal, left and right. So this is a horizontal reflection. Likewise, to reflect on the x-axis, we let y equal negative y. And once again, just so that we're not so confused, since it's reflecting on the x-axis, we're changing y values. Think of this instead as a vertical reflection. Now to really emphasize this, since the y-axis goes vertically, to reflect this point, we let the x value become negative x. So if this is 1, a reflection here would be negative 1. So it's a horizontal reflection, but the y-axis is the mirror that it's reflecting on. And this logic applies also to a vertical reflection, where if we want to reflect on the y-axis, this y value becomes negative to reflect on the x-axis. But instead, horizontal reflection and vertical reflection. So reflections on the axes make the x or y coordinates equidistant on the opposite side of the reflected axis. So we'll demonstrate to you this graphically, but first let's take a look at the algebraic applications of reflections. Now, once again, for these sorts of expressions, best to work with a factorized version of this. So factoring this would become x plus 6, x minus 4. So f of x is this factored form that we're going to be working with. Now a horizontal reflection for this, remember horizontal reflection, we're going to let x equal minus x. So in our transformation notation, we get y equals f of x. And now when we apply this transformation, x becomes negative. So we get y equals f of negative x. Now applying this to our function, this becomes y equals, notice once again for this, I'm leaving space for the substitution. And in a different color, just to see it happen, it becomes negative x, where x once was. And now to resolve this, let's take a look at some extra factorizations that we can do. In this first bracket, I can factor out negative 1, which gives us x minus 6. There's a times in between here. I'm just writing that to really show that now I'm going to factor out negative 1 from this group as well. So negative x plus 4. Just to really emphasize this, if I were to multiply out that negative back in, I would return to this group. Likewise with this, if I multiply it back, I would get back to this group. Now, since these two negatives are multiplying, they cancel out to become a positive, giving us x minus 6, x plus 4. So this is our new transformed expression. Now, to really show why you might want to do this one rather than this, you can utilize this expression in order to substitute negative x. We would get, so y equals f of negative x. If I were to now substitute this into the original expression, I would get this. So I'm actually taking this original expression, and now I substitute negative x into those. So I get negative x, negative x. So now negative x squared gets us x squared. 2 times negative x gives us negative 2x, and negative 24 remains the same. Now this, if you were to now try and factor this, you would actually get the exact same thing. You would get x plus 4, x minus 6. So either working in the factored form or in the original expanded form of this expression, you would still get the same final transformed function. And so now applying this graphically, going back to this, reflections on the axes make the x or y coordinates equidistant on the opposite side of the reflected axis. Since we are reflecting on the y-axis, negative 6 becomes positive 6. And negative 4 reflected on the y-axis becomes negative 4. Likewise, the x-axis being negative 1 here becomes positive 1. Notice how the y value doesn't change. And so this point here, which would be negative 24, that y-intercept, if it's reflected on the y-axis, there's no change that would happen. And so our new graph would look something like so. And there we have our transformed function. Now let's apply this to a non-function. So once again, a common thing that we'll find in this course is doing this on circles. So if we were to do this on a vertical reflection, so this is a reflection on the x-axis, we're going to let y become negative y. So now, for this, in this expression, so I'll just demonstrate it here. Copying this out, x minus 4 squared plus equals 25. So notice how I've just copied out the original circle equation and leaving space for this substitution. So now we're going to substitute negative y here. And we're going to simplify this expression. Now in gray, I'm going to show you what's happening here. So you don't have to always write out these steps, but I'm showing you what can happen. So negative y times negative y. So since this expression is squared, there are two groups. So there are two values of that group. I'm going to factor out negative 1 from this first group, so negative y plus 3. And in this group, I'm also going to factor out negative y plus 3. And remember, there's a times in between this. And so now these two negatives cancel. So this would just give us y plus 3 squared. So all of this can be done in one step. So from here to here can be done in one step, but if you don't understand what's going on in the background, you might get lost as to why this negative 3 would suddenly become a positive 3. And so now sketching this, this 4, 3, the y values, since this is 3 units above the x-axis, this center would be the same x value, but it would be 3 units below the x-axis. So this point here would now become 4, -3. Likewise, this point here, since it's 3 units above the x-axis, it will now be 3 units below the x-axis. So this would become 9, -3. And this process would repeat for all the y values of this circle. So this point would also become a -3 for the y value. So -1, -3. This point, its y value would become -8. So here, this would be 4, -8. And this value here, 4, -2, that, since it's 2 units below the x-axis, it will now be 2 units above the x-axis. So that point would become 4, +2. I hope you can see the circle being formed here. Obviously, since this is a sketch, it's a bit off. But as you can see, I can just easily move those back. As you can see, the idea remains the same, and that this point here, since it's on the x-axis, won't change. Alright, so I hope that gave you a quick revision on the applications of reflections. Hope to see you in the next video where we do rotations. Hope to see you then. Best of luck.